Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. For decades, when archaeologists wanted to understand what ancient humans ate, they relied on bulky evidence. Animal bones found near hearths, tool marks, and geographical context. But these methods provided only a partial, and often biased, picture, favoring durable meat scraps and ignoring the fragile world of plants, seeds, and micronutrients. We thought we knew what the Paleolithic menu looked like. We were wrong. The real story of human diet, a history spanning millions of years, isn't written on cave walls or etched in stone. It's calcified on the very instrument we used to eat, our teeth. Welcome to the residue revolution, where the humble, often ignored dental plaque, now fossilized calculus, is unlocking the deep secrets of our ancient meals. Dental calculus, or hardened plaque, is essentially a mineralized bioarchive. When we eat, tiny particles of food, bacteria, and saliva combine to form plaque. If not brushed away, this plaque absorbs calcium and phosphate from saliva and mineralizes, hardening into a stone-like substance. Crucially, this rapid mineralization traps and preserves fragile organic material that would otherwise decompose immediately after death. Think of it as a microscopic time capsule cemented directly onto the enamel. For hundreds of thousands of years, every bite, every medicinal herb chewed, every grain ground between the molars, left behind an indelible, microscopic signature. So, how do scientists read this archive? They use a technique called dental calculus microchemistry and microfossil analysis. Scientists take a tiny scraping of the ancient calculus, often just a few milligrams, and dissolve it gently in acid. What remains is a treasure trove of evidence. First, they look for phytoliths. These are microscopic silica structures found in plant cells. Different plants produce uniquely shaped phytoliths. Finding rice phytoliths in the calculus of an individual 10,000 years ago, for example, proves they ate rice, even if no macroscopic grain remains were found nearby. Similarly, they look for starch granules, which are the primary energy storage units of plants like tubers and cereals. If these granules show signs of heat damage, it proves that the ancient person used fire to cook the plant material, making it safer and easier to digest. This evidence has fundamentally challenged the long-held myth of the hyper-carnivorous, pure meat, caveman. Studies on Neanderthal calculus, for instance, have shown sophisticated use of complex starches and root vegetables, suggesting their diets were far more varied and geographically adaptable than previously assumed. They weren't just eating mammoths. They were managing a nuanced, seasonal diet, including nuts, berries, and medicinal plants like yarrow and chamomile. Beyond basic identification, scientists are using advanced techniques like lipid residue analysis and even ancient DNA, ADNA, extraction from the calculus. Lipids can reveal fatty acids from specific animal or dairy sources. And the ADNA? Researchers can identify the exact species of bacteria, plants, and even animal tissue trapped inside. This offers an unparalleled level of specificity, revealing not just that they ate plant stuff, but they ate this specific wild barley, or that type of moss. Furthermore, the calculus provides unique insights into ancient medicine. Evidence has been found of individuals deliberately chewing plant materials, like poplar bark, which contains salicin, a natural painkiller precursor to aspirin, to treat dental abscesses or infections. This isn't just a diet reconstruction, it's a look into behavioral health and ancient pharmacology. The residue revolution demonstrates that the shift to complex diets, including the processing and cooking of carbohydrates, happened far earlier and more universally than previously thought. The next time you visit the dentist, remember that the scraping tool isn't just removing unwanted debris, it's touching a potential library of human history. The information locked within that microscopic material is rewriting the textbooks on human evolution, one ancient smile at a time. The teeth, it turns out, are the ultimate silent historians. For more incredible facts like this, don't forget to subscribe and turn on notifications.